Hey everyone, Nick Raboy here from MongoDB. In this tutorial, we're going to be looking at modeling our BSON documents in our collections as native Go data structures. So this is another tutorial in our Getting Started series. This is coming after our CRUD operations. So if you haven't seen any of the previous tutorials in the series, such as creating, retrieving, updating, deleting, or even connecting to a cluster, take a moment to go back and look at the material. This is just an extension of that. We're going to be making our lives hopefully a little easier when it comes to working with our documents, and this is all going to be done using the Go programming language. So on my screen, you'll notice that I do have MongoDB Atlas up. So this is a database that I have called Quick Start. There's two collections in it called Episodes and Podcasts. These should look familiar to you if you've been keeping up with the series. So inside the Podcasts collection, I have one document. It's quite simple, but it's going to be important when it comes to modeling our documents as native Go data structures. Likewise, if we go into the episodes collection, you'll notice that I do have two documents, but what's important is the schema of these documents once again. So let's go into our application code. So this is code that I took from a previous example. What we're doing here is we're basically connecting to our MongoDB Atlas cluster. We've defined the handle to both of our collections, and we are doing simple queries against those collections. So for example, in both of these queries, all I'm doing is returning all documents from that collection, and I'm doing so for podcasts as well as episodes. Now if I run it, let's go ahead and take a look. Go run main.go. You'll notice that if I scroll up here and look at what we've got two maps that were printed out. The first one would be our one document from our podcast collection, and the other print statement would be our two documents from our episodes collection. Now, why would you even want to map your native Go data structures to BSON documents? Well, for one reason, you likely don't get type ahead or autocomplete when it comes to working with maps or interfaces, whereas you would with native Go data structures. There's certain error handling sides of things, and it's just overall very convenient to work with a Go data structure versus some kind of interface or map or document. And you'll see that as we progress. So let's go ahead and clear our terminal. I'm going to shrink it down just a little bit so that way we have some screen real estate. And we are going to model our collections. So if I go back in Atlas, this is what I mean. So we're going to model this data as Go data structures. So let's start things off. Let's go back into our code. Let's go to the top above our main function, and let's add the following. Let's go ahead and say type podcast struct. And inside of this struct, we're going to have an ID. This ID is going to be of type primitive .object ID. And what's important here is going to be the annotations. So just like when you can annotate JSON or XML or CSV, with the MongoDB Go driver, you can also add BSON annotations. And that's what we're going to do. So I'm going to say BSON, and I'm going to say ID. I'm going to say omit empty. Now let me explain a few things here. First of all, the ID, underscore ID, that comes from our document. So we have underscore ID. Even though that I'm looking at the episodes collection here, we have underscore ID, which we're going to map to an uppercase ID. The omit empty means that if I don't provide data for this particular field, instead of creating a nil or an empty string or something inside of MongoDB, it's just not going to include that field at all when you save it. You don't have to use omit empty. It's just whatever fits your needs for your particular use cases. Let's go ahead and add more to this podcast. Let's go ahead and add title. Title is likely going to be a string. We're going to have BSON. This is going to be title. Again, I'm going to say omit empty because for my needs, I don't want empty values to be inserted if I fail to include some kind of value for these particular fields. Next up, we have author. This is also going to be a string. And finally, I have tags. And this is going to be a slice of string. And we're going to say BSON. We're going to say tags, omit empty. Now, just to confirm, take note of what I have here on the screen from lines 15 through 20. What we're going to do is we're going to go back into Atlas, and we're going to click that podcast collection. And you'll notice that I have an ID, and I think I put title instead of name, author, and tags. So let's change the title to name. So let's go back into our code. I'm going to say name. This is actually going to be name. And these two don't have to match. I could have left title here, but name here. It doesn't matter, but for consistency purposes, for my own kind of benefit, I am going to name them the same. Now let's go ahead and take a look at the other collection. Let's go ahead and say type. We're going to say episode struct. And what we're going to do is we're going to say ID primitive.objectID. We're going to say BSON ID, omit empty. We have a podcast. So podcast is going to be an ID, because if I go back into Atlas and I click on episodes, you'll notice that podcast is an object ID, because what it's doing is it's actually referencing the ID of the podcast collection documents. We're going to see how to work with that more in depth when it comes to the aggregation examples, but that's out of the scope of this particular tutorial. So we have podcast, title, description, and duration. So let's take note of that. So podcast is going to be a primitive.objectID. We have title. We have description. And finally, we have duration. All right, so our Go data structures now match what we see in our MongoDB Atlas collections. So now let's make use of them. Let's swap out this BSON map, even though that it is perfectly acceptable. We're going to swap out this slice of BSON map with our actual data structures. So let's take it for a spin. Let's go ahead and say podcast is going to be a slice of podcast. And basically that's it. So let's go ahead and change this again. So this is going to be a slice of episodes. And we're going to see where things get a little more creative in just a moment. But we're going to say, in this example, episode. Now if I run this, I'm going to say go run main.go. And you'll notice that more or less we're getting the same results. The difference here is instead of it's returning a map, it's now returning a object for our Go data structure. And if I wanted to, what I could do is I could say something like episodes dot title, and it kind of gives me that type ahead kind of look and feel. It also allows us to do any kind of specific error handling. There's a whole lot of other things that we can do as well that come with the benefits of actually using Go data structures. So let's do one more thing other than querying. Let's go ahead and clear that. What I'm going to do above, before we even start doing our reads, let's go ahead and do a write. Let's go ahead and write a new document to MongoDB Atlas. So what I'm going to do is I'm going to say maybe my podcast, or let's go ahead and say Mongo podcast equals, we're going to say podcast. And let's say, for example, we have a title, or in this case, actually a name. So the name is going to be the MongoDB podcast. We have a description, or no, actually we have author. I'll scroll up a bit. Let's see exactly what we have. We have author and tags. So author, let's go ahead and say Nick Raboy. And tags, let's go ahead and say maybe MongoDB, maybe NoSQL. Let's just save it at that. We need a trailing comma there. So we have Mongo podcast. Let's go ahead and save that. Let's go ahead and say podcasts collection dot insert one. It expects a context and it expects our document, and it returns a insert one result or an error. So let's go ahead and say context, and let's go ahead and say Mongo podcast. See why we have some errors here. So we have an error right here because we forgot to do the following. So this is a slice of string, so it should be defined as such. So that removed all of our errors, actually. So let's go ahead and look at our insert result. So let's go ahead and say maybe insert result or error. And we're going to say if error not equal to nil, let's go ahead and say panic error. Otherwise, maybe let's go ahead and do something with that insert result. So we're going to say fmt.println. Let's go ahead and say, actually maybe, let's go ahead and say printf. Let's go ahead and say inserted v for value. And we're going to say maybe insert result dot insert ID. So what it's going to do is it's basically going to say inserted and then the ID of the inserted document. Let's go ahead and save it. The errors went away. Let's go ahead and clear it. And let's go ahead and run it again. I'm going to pull this up a bit. So it says inserted. I forgot to add a new line character to the end of it. It inserted an ID. If we look up here, we have two podcasts now. So the Polyglot Developer Podcast as well as the MongoDB Podcast. So it printed out two. And then the other one stayed the same because we don't have any episodes beyond what was already there. So let's go ahead and look in Atlas. Let's go ahead and go to podcasts. And you can see now that we do have both of our podcasts there. And you can see that if we look back in our code here, I'll shrink this down. It was actually more elegant to work with our documents as Go data structures. So not only is it more convenient, in my personal opinion, to retrieve our documents and store them as a Go data structure, but it's also more convenient to create our documents in the same fashion. So you just saw how to work with native Go data structures and kind of design them after our collection documents by using BSON annotations using Go and the MongoDB Go driver. Even though that in this particular tutorial, I didn't demonstrate how to install the driver or how to include any of the headers. So that's part of a previous tutorial that we explored in the Getting Started series. The focus of this was strictly around mapping those documents as native Go data structures.